Hello everyone, myself Avnish Tiwari, Assistant Professor in Civil Engineering Department at Sri Ram Swaroop Memorial College of Engineering and Management, Lucknow. Today in this lecture, we are going to discuss about laying and testing of water supply pipelines. Following topics will be discussed: structural requirements of pipe, laying of water supply pipelines, and next one is testing of water supply pipelines. So, what is structural requirement of water supply pipelines? Basically, the pipeline which we are going to design for the purpose of water supply, that should be capable of withstanding all the external as well as internal loads, and its own weight and different dynamic force acting on the pipe was also considered. When we group all the different forces, following forces comes into the play. First one is internal pressure of water, and this internal pressure of water includes water hammer pressure, and this water hammer pressure will be resisted by the pipe material itself, and the pipe material which is used, it should be strong in tension. Next one is pressure due to external loads. Pressure due to external loads includes backfill, means the external loads can be in the form of backfill or in the form of traffic loads, and this type of pressure is again resisted by the pipe material, and that pipe material should be strong in the compression. In case of water hammer pressure, the pipe should be strong in tension, while in case of external loads, the pipe should be strong in compression. Coming to next stress, that is longitudinal temperature stresses. This type of stress comes into existence when the pipe are laid above the ground, and this type of stress can be resisted by providing an expansion joint. Okay. Next one is longitudinal stress, and this longitudinal stress is due to unbalanced pressure, and this unbalanced pressure can be seen at bends or at the point where pipe changes its cross section. How this type of stress can be resisted? This type of stress can be resisted by firmly anchoring the pipes in a massive block of concrete or stone masonry. At point A there is a bend, and at that particular point there is a development of unbalanced force, and because of that unbalanced force there will be development of a longitudinal stress. Okay. Coming to next stress, that is flexural stress. Flexural stress produces when the pipe are supported over the trestles. For example, these two are supports and the pipe is passing above it. What will happen when water will flow through this pipe? The pipe tries to bend, and there will be development of flexural stress. What will be the internal pressure of water, or how can we calculate it? As the pressure exerted on the walls of pipe by the flowing water in the form of hoop tension, the value of circumferential tensile stress will be sigma equals to P into D, sigma equals to P into D by 2 into T. How can we get that value? Consider a pipe. The pipe is having a thickness T. Okay. So, there will be existence of pressure and that pressure will be registered by stress. So, here develops a stress and that value is sigma. Similar stress will develop on that side. What will be the value of force? In order to get the force, what we will do? Simply we multiply sigma by area, sigma into area, and what will be the area? Its area will be equals to sigma into L into T, means basically what is the length and what is the thickness of that particular pipe. As the stress development on both of the side, so it will be multiplied by 2, means force develop 2 sigma L into T. And what pressure applied by the water? That pressure will be on that point or that particular portion. So, if we draw its top view, it will be like that. The pressure exerted by water from that much portion, and in order to get the value of force, what we will do? Simply we will multiply pressure into area. What will be the area? Its area will be diameter into length of pipe. Equating both the values, what we will get? P into D into L equals to 2 into sigma into L into T. L cancel out and sigma will be what? Sigma will be P into D by 2T. So, this is the value of sigma. And how can we get the value of sigma? So, here sigma is circumferential tensile stress, P1 is the internal static pressure, its unit is in kilonewton per meter square, T is thickness of pipe in meters and D is diameter of pipe in meters. Next one is water hammer pressure. So, what is water hammer pressure? Basically, when a liquid flowing in a pipeline is abruptly stopped, and how can we stop it? By closing a valve, the velocity will reduce to 0, and if the velocity reduces, then what will happen? Momentum is destroyed, means momentum also reduces, and this exerts a thrust on the valve and additional pressure on the pipe cell behind. This is the case. Here the water is flowing continuously. If we are going to close the valve, what will happen? The valve is closed and the flow of water is abruptly stopped, and the flow of water exert pressure on the valve as well as the surrounding cell of pipe. And what results? The more rapid the closure of valve, the more rapid is change in momentum, and greater will be the internal pressure developed. Means rapid will be the closure of valve, rapid will be the change in momentum, and greater will be the development of additional pressure. And this pressure so developed are known as water hammer pressure. The pressure developed because of the sudden closure of valve will be known as water hammer pressure. And what will be the result? It will cause the bursting of pipe. So, 10 times what will happen? The pressure is too high that it bursts the pipe. And how can we calculate that particular pressure? For estimating the value of water hammer pressure, we are going to use expression P2 equals to, here P2 is what? P2 is water hammer pressure, 14.762 into velocity, V is what? Velocity of water flow just before closing the valve, and it is in meter per second. What is D? D is diameter of pipe, and what is T? T is the thickness of pipe, and K is constant, which is the ratio of modulus of elasticity of pipe material and bulk modulus of elasticity of water. How can we get the value of K? Basically, the value of K for steels comes out to be 0.01, means for different pipe material the value of constant K will be different. For cast iron pipe the value of K is taken as 0.02, and for cement concrete pipe the value of K is taken as 0.1. And while designing the water supply system, what the value of water hammer pressure should be taken as? For design purpose, if values are not given, we can take this much of water hammer pressure for different diameter of the pipes. Okay? And this water hammer pressure can also be calculated by using the formula mentioned earlier. And the circumferential tensile stress, next what we are going to do, we are just going to convert water hammer pressure in the form of stresses. The circumferential tensile stress produced by water hammer pressure will be what? Sigma equals to P2 into d by 2t, where P2 is what? Pressure because of water hammer action. Okay? And next is stress due to external loads. These external loads are backfills which produces stress in the pipe material, and this stress can be simply calculated by using the expression that sigma equals to 22.7 into h into d square by 2, where sigma is stress produced in kilonewton per meter square, d is the diameter of pipe in meter, t is the thickness of pipe, and h is what? H is the depth of earth which is taken above the crown, means if this is a pipe and this is a portion where the pipe are laid, the pipe is laid, what will the value of h? H will be this much. Okay. So, h is what? H is the depth of earth fill and it is taken above the crown. In above formula, it is assumed, if basically the formula is derived by having certain assumptions, it is assumed that earth to the side does not give any lateral support and the weight is about 18.4 kilonewton per meter cube. Coming to next, that is temperature stresses. This type of stress develop because of variation in temperature, and this generally comes into existence when the pipe is laid above the ground, means pipe is exposed to atmosphere, and when the pipe is exposed to atmosphere there will be change in temperature and the pipe will expand during daytime and contract during night time. So, our target is to neutralize this expansion and contraction. So, this expansion or contraction can be prevented by using expansion joint. We can control it by providing an expansion joint. So, if this expansion or contraction is prevented due to fixation or friction over the support, longitudinal stress are produced in the pipe material. Okay. So, there will be development of longitudinal stress. What will be the value of temperature stress? Basically temperature stress equals to E into alpha into delta T, where E is what? Modulus of elasticity, alpha is coefficient of thermal expansion which is dependent upon pipe material, and delta T is what? Change in temperature. And in order to counteract that stress, the expansion joint provided, it should be at an interval of 20 to 30 meter, and that counteract the temperature stress. Next one is stress due to flow at the bend, where what is developed? There is a development of unbalanced pressure. So, whenever the velocity of flow changes and that change should be in the form of magnitude and direction, what will happen? There is a change in momentum. What will happen? There is a change in momentum, and we all are aware that according to Newton's second law, force should be exerted because force is directly proportional to change in momentum. Okay? The force required to bring this change in momentum comes from pressure variation within the fluid. Okay? There is also possibility that if the cross section changes, there will also be a pressure variation. Okay? Pressure variation, and from forces transmitted to the fluid from the pipe flow. And when we are going to draw the free body diagram, the diagram should be like that. Okay? What is this? This is the section 11 and this is section 22. What will be the force? Here force will be pressure multiplied by the cross sectional area at point 11, and what will the force at point 2 at section 22? Here the force will be pressure multiplied by area at section 22, and there also comes a force in direction x and a force in direction Fy. And what we are going to do, just we are simply going to equate force equals to change in momentum, force equals to change in momentum, and after equating that we get the values P1 A1. What will happen? There will be the force in x direction, that is P1 into A1. Fx comes into existence in opposite direction, that is why minus x. Here the force P2 A2 acting in this direction. When we are going to resolve it, then when we are going to resolve it, what will happen? This is the value, this is theta, this is theta. What will be this? This is again theta, and what will that component? That is P2 A2 cos theta. Okay. So, again in opposite direction, so minus of P2 A2 cos theta equals to mass, and mass can be written as what? Gamma W by G into K. This gives us mass, and what will the velocity? Change in momentum equals to mass into change in velocity. Here what will the velocity? Here at point A velocity is what? V1, and here what will the velocity? Here velocity will be V2. When again we are going to resolve it, the component comes in x direction is V2 cos theta. So, final velocity minus initial velocity, that is V2 cos theta minus V1, and in Fy direction the force acting upward, that is Fy. So, it is Fy. The force in downward direction is P2 A2 sin theta. So, that will be Fy minus P2 A2 sin theta equals to change in momentum mass into velocity. The component of velocity in y direction is 0, and the component in y direction is what? At point 2 is V2 sin theta. So, this can be written as V2 sin theta minus 0. So, by using these two equations we can estimate the value of Fx and Fy at a point where bend is observed. Next one is flexural stress. So, coming to flexural stress, basically this type of stress develops when the pipe are laid above the ground and supports are given at regular interval. What will happen? The pipe will act like a beam and the columns will act like a support, and when water will pass through it, the weight of water as well as the weight of pipe itself tries to bend that particular pipe, and by resisting that particular load or that particular self weight of pipe, there is a development of flexural stress. Okay. So, this is a form of stress which develops in a pipe because of supports. Next comes to laying of water supply pipeline. So, basically pipes are used for conveying water from source to city and also for distributing the same within a city. So, it can be used for transmission of water from source to city and then distributing the water in the city, and this pipe can be laid above the ground or below the ground. Okay. It can be laid above the ground or below the ground. Generally the pipe bringing water from source to city are laid on the ground. This is a picture which is just showing how the pipe is laid above the ground. Okay. Whereas the pipe used for distributing, because distribution system is designed in a city, and it is not practically possible that the pipe is always exposed on the ground or above the ground, then in that case the pipe is laid below the road and streets. When the pipe is laid on the ground, what will happen? We have to compact the ground surface, that ground surface should be compacted, okay? And why compaction should be done? Compaction should be done in order to avoid settlement in the future, and it is mandatory that the pipe should not be laid just above the ground. It should be laid over small masonry or cement concrete support at an interval of 16 to 12 meter apart. Okay? This arrangement will be helpful in order to perform the maintenance work, repair work or inspection work. This flow diagram will just represent the step involved in laying of a pipe network. Firstly, what we have to do? Basically, we have to line out and excavate the trench, and after the excavation of trench, what we are going to do? Just we are going to use pipe of suitable length, and after getting the pipe of suitable length, we are going to just lower the pipe in the trenches, and after lowering the pipe in the trenches, what we are going to do? We are just going to join the pipes. After joining the pipe, we are going to partially fill the trenches. Why partially filling the trenches? Because we have to perform pressure test. Okay? After performing the pressure test, we can completely fill the trench and compact it. Okay? So, these steps are just elaborated in the following steps. So, in order to line out or draw or just we have to mark the distribution system, we need a detailed map which shows a road, street, lane, so we can plan for it. And after getting the maps, what we are going to do? Just we are going to draw the center line of pipe, and this center line of pipe should be transferred on the ground. And after transferring the ground, what we will do? Basically, we are going to excavate it, and while getting the excavation, certain points should be remember that the width of trenches should be 30 to 45 centimeter more than the external diameter of pipe, and at the point where we have to make joints, the depth of excavation should be 15 to 20 centimeter more and for 1 meter of the length, so that joining of pipe should be easy. Okay. So, next one is the pipe should be laid more than 90 centimeter below the ground. Why 90 centimeter below the ground? Because of that the impact of traffic load can be minimized. Okay. And after performing the excavation, the pipe are lowered in it, and after getting the pipe lowered, what we are going to do? We are simply going to join it, and after joining it, we are going to perform water leakage and pressure test, and after successfully completing the test, what we are going to do? Basically, we are going to just fill the trenches and compact it. Next one is testing of water supply pipelines. Coming to testing of water supply pipelines, few points should be known by everyone, that is working pressure. What is working pressure? Basically, working pressure is actual maximum pressure, also including water hammer pressure, to which the pipe will be subjected during its operation. What is design pressure? Basically, design pressure is a maximum pressure for which the pipe has to be designed, and this is obtained by simply multiplying the working pressure with factor of safety. When we multiply working pressure with factor of safety, we will get design pressure. Next is test pressure. Test pressure is a maximum pressure which pipe can withstand without any leakage when we are going to test it for the leakage. Okay. After laying of pipeline, the soundness of construction is examined. And how it's examined? Basically it is examined by performing the test, and the pipe is tested section by section, and at a single time we are going to perform testing of a single section, and that particular section should be between two sluice wall. The downstream sluice wall should be closed and water is allowed to enter from the upper sluice wall. Okay. And next is that we have installed pressure gauge at different pipes of the different point of the pipe along the length of pipe section at a suitable interval, and that is 1 kilometer interval. And next one is the pressure of pipe is raised by means of a small hand force pump or a hydraulic pressure pump till the test pressure is achieved, and this test pressure is about 25 to 55% above the highest working pressure. Next one is the pipe and joint are then visualized for water tightness. The applied pressure should be maintained for at least 4 hours. Okay, the pressure applied is maintained for 4 hours. When field test pressure is less than third of the work test pressure, then the observation period should be increased to 24 hours. And after testing the pipe, if observation comes that there is a leakage, then what we are going to do? Just we are going to repair it, and after repairing it we are again going to test it, and if the test comes satisfactory, then that particular supply system will comes into existence or comes into our use. These all are the references.